Okay, maybe we can start like with the first intro. First of all, welcome to the second edition of Talking Minds, a series of events. Today with me I have Mr. Nikola Mrksic, who is the CEO of PolyAI. PolyAI is a London-based conversational AI startup where they are like serving large enterprise clients in the domain. Before like starting PolyAI, Nikola was a part of Apple. And also first engineer at VocalIQ. He completed his PhD at Cambridge, working with Professor Steve Young at the Dialogue System Group. So far, PolyAI succeeded to raise more than $14 million in VC funding. Once again, Nikola, thank you for being with us here today.
Oh, thanks for having me.
Great. I need to say one more thing. This event is also powered by a new organization, which is called Serbian AI Society. Our organization with the goal actually to become a global influencer in scientific advances that will actually boost innovation and that will help also our ecosystem and our future society to be more knowledgeable about AI. This is our, as I said, second edition. First time actually we got nice feedback and really nice impression from the crowd, where we started with the quotes, and I will use that as well today. Where one quote for me that was interesting is saying actually that maybe it's a quote from Rumi. That guy was pretty famous in like 13th century, like a poet and a philosopher. And he said that, okay, maybe we are searching among the branches for what only appears in the roots. And yeah, today our conversation will be around conversation and understanding, etc. And if you're talking about the roots of understanding, Nikola, can you tell us a little bit more about that? What's understanding? What are the roots of understanding if you're talking about like a human intelligence in human conversation?
Yeah, so I'm not much of a neuroscientist, right? And just in terms of how we as humans do it, I think, well, I mean, we don't really have a good, clear understanding of exactly how we do it, and much is true of anything to do with like how humans do things and how we're trying to get machines to do intelligent or seemingly intelligent tasks. When it comes to understanding, there is like a point of view of like actually building these systems, and it's what we do, and it's what a lot of companies do, where you're trying to understand what, say, the user means to what the person you're speaking with is trying to say at a given point in time in the conversation. And in understanding, you bring in a lot of context, right? So say in this conversation that you and I are about to have, we're going to probably exchange what's probably like 500 dialogue turns, going back and forward to speak. But like, unlike a conversation with machines, at least in the way that it's, designed right now, we assume this very kind of like strict turn-taking paradigm where I say something, then you say something. And we're probably going to talk like that now because we're not in the same room. We're speaking in front of an audience, and, we're doing it to kind of like make the whole conversation presentable. But what actually happens in a real conversation is that, what's equally important is the amount of non-verbal cues, right? So for example, if I see that you're frowning, you're probably skeptical about what I'm saying. I need to be more persuasive. Or, if you're nodding aggressively, you're probably agreeing, and I can probably like speed up and talk about something else. But also when we understand things, right, especially like things that are imbued with more meaning or potentially ambiguous or interesting, we bring in the whole context of our life experience, right? And when I speak to you, I'll speak differently, especially if I'm a good orator, or if I'm very persuasive, I'll speak differently to you to how I speak to, say, someone else. And in doing that, I'm modeling both what I assume is your kind of like state of mind, knowledge, biases. Biases are very important. And I think, when you look at like the task of modeling communication with computers, it then gets a bit philosophical, right? On the one hand, it can be like a very utilitarian conversation. Like, I'm helping you make a reservation for a restaurant, and you call me, I check my reservation book, and I'm like, all right, like, two people at 6 p.m. You've got it done, right? And the only thing I really need to understand there is like what time you want to come in, what day, the number of people, maybe you have dietary requirements, or maybe you don't want to sit by the toilet, right? And I'm going to note all that and we're done, right? And that's something that technology can do right now. Not really well. It's not easy. It's still a lot of heavy lifting to even get something like that to work really well, especially if we're doing it with speech rather than with text, because speech recognition is a whole new layer of technologies that adds noise to the process. But if you want to build a different kind of system, something that would maybe, attempt to solve the Turing test, which I maybe just for context, I can, the Turing test is this, I forget the exact origin, but it's something that's been going on for the Turing test challenge has been going on for quite some time, where you're basically asked to speak to a system. And if a certain proportion of time you're unable to distinguish between the human and the system, we deem the system to have passed the Turing test. And then, like, according to some people, that would be like a good measure of like AI learning to speak and, like mimic human intelligence. It makes no sense in the world. It can be done with all sorts of deflection tactics, and it's a challenge for the sake of the challenge, right? But when you attempt to build those kinds of systems, you're going to have to ask, like, well, why are you doing it? Are we doing it to build a social companion, or are we doing it to really understand intelligence as a kind of like an AI complete problem, which links to all others? And there it gets really complicated. And I've kind of rambled on, and I'm not sure if this was interesting for people, but happy for you to take me into any direction you see fit.
Yeah, I think that's pretty interesting for people. Yeah, there are a lot of challenges currently around, of course, hype around AI, etc. And if we are talking about like also natural language processing, it's a really hot topic all over the place. Like people are trying to investigate and to find the new models that will be able to understand some really plastic kind of conversation examples where, okay, you mentioned, okay, we as a human species, we are pretty able to be flexible and adjustable in the sense of like having feeling how to adjust our conversation to be more persuasive, or need to be like more aggressive in some sense, etc., etc. But if we are talking about the machines and like current stage of natural language processing, can you just like structure, summarize where we are currently, what's possible, what's not possible at all? Your company is doing pretty interesting things, and yeah.
Yeah. I mean, I guess, I mean, I can tell you about PolyAI later, but like, when you look at NLP, like in very broad strokes today, there are a few sub areas that are really hot, right? And, if you looked at the field maybe 5-10 years ago, things that people were interested in would be like text classification. Like, is this, text article about sports, or is it about politics, right? They're kind of like small tasks where we're kind of like building muscle, right? Today, it's about more composite tasks. And, I mean, I'm really happy that conversational AI or spoken dialogue systems have become really hot, and one of the kind of like central pieces that people are working on. And there, again, it breaks down into a bunch of different areas, but we're trying to build things that are, capable of understanding, that are capable of holding a conversation, perhaps capable of entertaining, or capable of helping you achieve a particular task. Other problems that are really hard in NLP and really interesting, at least for me, are text summarization, which is a really, really difficult thing. Knowing what's important and like synthesizing it into kind of like smaller piece of text. That's something that's really cool. But what's been like a big trend in NLP over the past, a decade by now, really, is like kind of like this big push of deep learning into what was previously a very, not a soft, but a softer field, right? When you look at the top conference in NLP, it's called the Association for Computational Linguistics, right? And there used to be a lot of linguists who would actually bring really mathematical and good formal logic, like, first order logic, like good abstract symbolisms for representing language, meaning, leading to, problems like semantic parsing. And that was a lot of good science that didn't lead to, I'm going to offend some people, but it didn't lead to too much exciting technology, right? Because it was hard to apply it, and it was basically designing a formalism for creating systems that do a particular task, which is cool in itself, but it didn't really allow for mountains of data to be used to build systems that are going to be very good. Because when you crack that and you have a lot of data, really good things happen. You end up building really good systems that deal with all the edge cases that they might have seen before in a really good way, rather than a handcrafted system where you're not able to do that. You have to account for every edge case yourself, like in regular programming, and that's something that's still at the center of conversational AI, right? Mm-hmm. Like this kind of like trade-offs between building a data-driven system, which is what all researchers are keen on, and like everyone in my company is a deep learning fanatic, right? Like we love things that are data-driven because that is how you build things that scale. And the beautiful thing about deep learning, for maybe I'm assuming that our audience is quite technical. The beautiful thing about deep learning, if you manage to build complex systems that are fully data-driven, then you can connect them with each other. And as they learn or continue to learn, the signal can back propagate, and hopefully the whole system gets better at everything. So say in conversational AI, there are a few subtasks within building a system that speaks. One is understanding itself. But the second bit that is as important is response generation. Like, how do you come up with an answer? And that actually depends on the world, right? If you ask me a question, I can only formulate an answer if I actually know the fact. Otherwise, I have to bluff in a convincing way, right? And to do that, you end up handcrafting again, because it's easy. And it's also something that, one really important bit there is, are you able to deal with edge cases where machine learning does unpredictable things? Because it will do unpredictable things. And the general pattern is, the more powerful the model is, the harder it is to debug, because it's not coded. It's a set of parameters that spits out random things. And then if you want to have like full control of it, you're going to have to add traditional control flow logic on top. And anyways, yeah, that's the mess that conversational AI is in. But it's a really fun mess.
But when you say like data-driven models and that your team is excited about that, and deep learning is really amazing technology that is actually showing its own capabilities currently. But do you think that like real intelligent systems are so data intensive as we have them right now, like on the market, or you think that we need some additional new things, some missing blocks are not yet among us? How do you see, like especially if we are talking about like a conversational systems? Okay, you need to have like facts around some things to be able
Absolutely.
to conversate, to have a dialogue, etc. But on a higher level, how you see it, okay, for like giving the proper answer, to know how to reshape it, etc.
Yeah. Data is just one part of it, right? Data is what helps when you've fully digested the problem and you have a very clear sense of what you're trying to do. And conversational AI is not there yet. You can make a few assumptions, say like we do, and then you have a problem that is well posed. But in general, when we say like conversational systems, we don't really know what we mean. We're trying to build a bunch of things. Alexa, Siri, they're very different systems to say the ones that we are building at PolyAI, which are voice assistants for businesses that provide a lot of customer service, and then they need like a set of transactions to be automated and to work well. And that's a lot easier than building a general system that you can talk to in any way you want, in any language perhaps that you want, about any domain that you want. Like, that's really hard because it's an endless problem. But the thing with data and how well posed the problem is, speech recognition was cracked with a lot of data. It was cracked with a lot of data because the input and the output are very clear. They were clear from the start. It's just the very nature of the problem, right? Like, you say something, and well, at least in most languages, there's, in Serbian definitely, in English as well, there's only one way you can write it down. And in that case, well, you've got a pretty clear problem, right? And then the more data you have, you do better, right? But there was a Wall Street Journal corpus, I think in the 90s, that really kind of like pushed speech recognition forward. And when you look at computer vision, like, again, that's a pretty complex, like, what does it mean? Well, like if we take a more narrow definition of a problem and you say recognizing an object, like, and you take a data set like ImageNet, the moment that we turned it into a well-posed problem with a lot of data, we cracked it really, really quickly. And my co-founder, he has this graph that he loves showing to people. When you look at three very hot problems in machine learning, right? You look at like game playing, something like chess. You look at computer vision. You look at speech recognition. The average time between the invention of the algorithm and then like the problem being cracked, by which, like Garry Kasparov lost to Deep Blue, or we got something that resembled human level transcription accuracy for a native speaker of English in a quiet room in a not very wild domain. Like it takes around 18 years. And it really, 18 years from the point that the model that cracked the problem eventually was invented, but 3 years after the kind of like defining challenge where people said, all right, that's it, we're solving it with this data set, right? And it's really about the data and the concentrated effort to do a specific thing. And in terms of conversational AI, it's not like understanding specifically, it's not clear how you need to parse it, right? There's maybe, there have been many attempts to, agree a standard for parsing a sentence so that it's like a clear, like formal logic representation, right? And semantic parsing is the subdiscipline of kind of like really, just kind of like parsing the whole sentence, both in terms of syntax, the grammar, but also then like the actual values and things that are kind of like key action points. Like I want to get a train from Belgrade to Novi Sad tomorrow, like, you'd parse it as like to from specific time. And like, that's something that conceivably then machines could use to actually go and book a ticket for you because they know exactly what you need. And when it comes to NLU, natural language understanding, there are a lot of challenges. There are systems that do quite well. And, we're part of this race. We compete sometimes senselessly and maybe, completely illogically, but it's fun and it's what engineers do, right? But in terms of actually saying like, hey, we're really close to the solution, we just need a model, I don't think that's it. I think we need a paradigm, right? And I think to do that, we need to define what it is that we're trying to solve, right? And the way we go about it at PolyAI is we've said, like, we want to build customer service, voice assistants for big, large enterprises that might have, 500, 1,000 call center agents. And, this is bigger than people think. 2% of the British population works in call centers. And the average churn goes anywhere between 40% and 200% a year, right? Because these are basically jobs that not many people want to do. And they might do them for a few months in between other jobs, and then they quit because they're basically paid minimum wage to do jobs that they really don't want to do because it's just people shouting at them for things that are not really, caused by anything that they did. So, and when you look at that, like automating a lot of those things, like that's a well-posed problem. You can look at the NPS score, which tells you like how happy the user was at the end of the interaction. You can look at CSAT scores, which tell you like, hey, like, has the problem been solved? And then, on a very technical level, you can, if you really want to, go and annotate everything that happened and see how well your system worked at any given dial of turn.
Yeah. And to go back, actually, I will have questions regarding like PolyAI and creating your business model and defining like the right problem that you are able to solve with current like technology. But today, like if you're talking about like computer vision, I would say that most of the problems are pretty solved. You can build different kind of a commercial application in variety of domains. Which could be monetized in some sense. But if you're talking about the natural language processing, you're pretty like strict. Also with the models, I would say in that sense, something that's interesting on the market is when BERT and the entire like hype around that actually started. We're currently like there are a lot of developers, engineers that are looking the ways how to use that kind of based models to deploy into their own like current problems in some sense. But how do you see, okay, the question is, okay, how do you see like BERT as a general purpose, like natural language like a model as a really heavy model for defining and putting that into real kind of application? And your approach where you can like define and just describe how you are like building things like internally?
Yeah, I mean, I won't go into excruciating detail about how we do things, but to go back to BERT, like BERT is a great thing, right? And like maybe to give a bit more context for the audience, traditionally, when you did natural language processing, if you did any task that required a sentence, right, you would say like which words are in the sentence, and you might create this like one hot encoding, it was called, where you just kind of like tick the box for each of the words that is present in the sentence. And then if you did sentiment analysis and there were words like happy, great, amazing, like it's a positive signal, and if there are words like terrible, disgusting, slow, whatever, that's a negative signal, right? So like, for example, that thing didn't really account for word order, and it was a pretty clunky way of doing it, but it worked for those simple tasks. Right? But it's messy, and it doesn't really lend itself well to generalization. Because even if you got like, if you take Serbian, for example, our words can have 7 different endings based on, where in the sentence they are. And if you saw a different version of the word, that kind of approach would be clueless. It didn't really know that, the 2 different conjugations of the word represent the same word semantically, if not, syntactically. And what you would have to do then is you would have to say stem the words when you turn them into the root of the word, but then you lose, for example, information about how it was used. And like in Serbian, that would matter, like for actually interpreting the sentence. So what became really hot around 2012, 13, 14 were word vectors, which are basically mathematical representations of words in a semantic space that's typically very high dimensional, say 300 is the norm, where, you might say that words in, like 2 synonyms for a word, like, I don't know, dog and hound might be very close, right? Or say in Serbian, pas, psu, and, all the other kind of like conjugations of the word dog would be close. They'll be lying around there. And when you use any one of them to activate another model, they would cause a similar reaction. And that just basically removed the need for a lot of the intermediate techniques, which were really painful. And they were a big barrier to academic research in NLP. Because if you think about, say, what was needed to build a dialogue system, you need natural language understanding, which in itself, because of those things, needed several different parts of the pipeline. Then you have like dialogue managers, which need reinforcement learning. And then you need natural language generation, which then again needs either a specific templating approach or a neural network. So if you wanted to start a research group doing this, you'd need like a few million and 10 years to set it all up, right? And that was a big barrier to entry. Now, when the whole thing changed, then we just said like, hey, words are going to be vectors. You can download a word vector collection from this link. And hey, everyone, go ahead and try to do things with it, right? And with the commoditization of things like TensorFlow, Theano before TensorFlow, PyTorch, and other deep learning frameworks, it became really easy for anyone to mess around with these things. And we got an explosion in the number of, first, kind of like, amateurs doing things, and those amateurs very quickly became proficient users of deep learning, and the whole field became what it is today, right? And like that was a really good thing. But if you think about like what it means for, what are we talking about?
Like general modeling.
BERT.
Yeah.
That's right. If you think about then like word level representations, you still need to assemble them into a sentence, right? And I spent my academic career doing that, training both, say, word vectors that are better at capturing the meaning, especially say across languages. And, say that's a really cool thing about deep learning, right? You're able to take a word in one language and another, create a cross-lingual space where, similar words are close, train a system in English, and then have it work in Serbian for, even though you might not have ever trained it in Serbian. And that's the power of pre-training that really, kind of like defines deep learning successes throughout. But then when you look at like, how can you push it further? How can you let anyone have a really good representation, right? And the next step clearly is the sentence, right? Because if there was a clear mathematical representation of the sentence, then we can throw it around other more complex composite models. And ideally, you'd be able to have any practitioner of deep learning have the same high quality model for a sentence representation. Then, if they want to build a dialogue system, they can do that. Or if they want to build a sentiment classifier, they can do that too, right? And like standardizing, unifying representations is a great thing. So I talked a bit about how like we don't have clear standards in NLP, and I think that a lot of people got really excited about BERT because it wasn't really, you know, a good formalism, but it's a very practical solution to that mess of like, how do different people represent it? How does it work? How do you bridge the gap between people with incredible amounts of data and people who don't have an incredible amount of data, right? So the hope was if Google pre-trains BERT and releases it, then, you know, everyone's on the same level playing field when deploying end applications. And the truth is, like, BERT is cool. It's also incredibly computationally expensive. But when you dig deep into any specific application and want to have state-of-the-art performance, frankly, you don't really need it. But it's useful. It is useful for having to have a lot less data if you plug it in the right way. Now, what we found in conversational applications is, you know, we were at the forefront of, you know, like fighting for those high scores and those challenges, et cetera. And we found that BERT is actually not very good at conversations because it's actually there to, you know, just like train a very general representation that you can use for simpler tasks, frankly. And what we were able to do is kind of like create a very different approach. Well, not that different, but different in a sense that it's based on a re-ranking paradigm where we're actually, you know, pre-training something like BERT, sentence representation, that is there to tell you if another sentence is a good response for the previous one. And that's what we use. Our model is called Convert. It's you know, a proprietary model. We've patented it. Then we released it so anyone can use it. And it's an interesting approach because, you know, we're able to, with 40 megabytes, beat BERT by, you know, close to double-digit percents in conversational applications. If you plug our model in for, you know, sentiment analysis or text classification, BERT is a lot better. But like with dialogue, with conversation, conversational AI, it's usually been the case that you need domain-specific representations. And we've not really been able to generalize to the point where we just say like, hey, BERT is better than anything, just use it and forget about the rest. But I think it's created a lot of good research. It was a step in the right direction, but it's not a panacea. It's not a solution. It's not a silver bullet.
Yeah. And when you say like domain-specific application, of course you need to train it like to be able to understand like a variety of like the types of dialogues, the ways how people communicate, etc. But are you able really to narrow it in some sense? For example, okay, you're doing really awesome things for the restaurants and customer support in that sense. Is there a way how you can like narrow like entire data pipeline there, etc., and to have like more focused models that will be for that domain?
Yeah, I mean, like you can specialize any general model with more domain-specific data to improve its performance for that domain. Like, or you can do what people did before. You know, BERT became a hot topic and just train much smaller models that are, you know, 1,000 times smaller and do an equally good job. So, you know, like in terms of like on-device applications, like you don't really need it. There's a way around. The beauty and the appeal of things like BERT is that they would unify how you did it across any application. And, you know, in theory, as you know, there's no reason why we can't unify our approach with BERT if we had infinite compute and memory, right? And like that kind of happens, you know, you get it for free in 10 years' time, right? I mean, people are greedy. We will always want bigger models and whatnot. But like, the beauty of it is that it unifies. It gives you like the same approach across whole things, like the same way that, you know, like you could implement everything in assembler right now for different like hardware pieces, but you really appreciate the fact that, you know, for most things that you do, you can use Python instead.
I just wanted also to encourage people to put the questions, and then we got two of them. Two from Laden. First one, yeah, we will start with also questions from our crowd. Nikola, what was the model you have fine-tuned with domain-specific data, and what was the TPU GPU build?
That's a very specific question. I need to get my CTO. It's depends for what. Dialogue is a very complex problem. There's natural language understanding, there's response generation, there's natural language generation. You know, what we use is a dual encoder that is pre-trained on a lot of data, mostly on Reddit, which is the best source of conversational data. In terms of like training, it's, we train it for a day. It takes a bit of compute, but it's not a monster in the we don't use TPUs.
Okay, and yeah, the second part that leads to another question: how you collect customer domain data to achieve high accuracy of your models?
We don't use customer data, especially kind of like following GDPR. That's something that you really don't want to do. And frankly, we see it as a competitive advantage because we spent many years building machine learning models with very small data sets because we didn't have large data sets, right? Like Sean, my co-founder, and I manually annotated a data set that he released in 2017. And, he did the first sweep, I did the second sweep, he did the third one, I did the fourth one, and I can assure you, annotating 600 dialogues has severe repercussions for your mental health. So, we didn't really want to annotate more. So when you build things with, to train with small amounts of data, then you don't really need a mountain of data. So there's not really a reason to use customer data. You can recreate data very similar to customer data, but you don't want to risk, the model remembering, say, someone's credit card number, like things that you could do conceivably with models like BERT, if they're trained on that kind of data, is say, my name is Nikola Mrksic and my credit card number is, and you rank all the possible candidates and you see what my credit card is, right? And because of the kind of like distributional semantics inherent in how these models pick up signals, that's something that you could probably do. And that would be quite a big failure mode. So in our approach, we typically work very hard to understand the use case, right? It could be technical support for gas stations, or it could be, say, appointment making. And then we build a system with data that we collect. And we've got very sophisticated pipelines for collecting data from, crowdsourcing platforms like Amazon Mechanical Turk.
Yeah. I hope that was a lovely period of your time when you had labeling and all other I would say shits in that period. But yeah, I believe that's one of the most fundamental challenges at the beginning, like especially if you're like building your own startups. Now, yeah, you can find a bunch of models that could be interesting for some specific domains, etc. But how you will reshape it and put it like in a structure, in that sense, that's really a challenge. And that leads me to the part actually where, of course, chatbots and a lot of hype around that, where in the last couple of years we had like a bunch of like estimation, like big titles around chatbots. They are smart, they are coming, etc. What's your thinking around that? Like where we are currently, what are the obstacles from that domain? Companies are trying to find like better customer support agents that will solve entire process, etc. But at the end, we have really shitty products.
That's a very blunt way to put it, but I agree with you. I think that, 2016, 2017, the age of the chatbot is coming. You will never call customer service again. It's going to be amazing. Like, inflated valuations, something like, 500 seed funded startups doing chat, all with a unique machine learning platform and a unique problem that they're solving. Most of them are dead now, as they should be. Because they really didn't have it. It's the nature of hype. It's the nature of how we innovate in the venture capital land. It's totally cool, right? Like it's how it should be. Now, when you look at chat, on its own right, like it's a deflection strategy. It's a band-aid that you put on a wound. It doesn't really fix it, right? Because deflection is a dirty word, or containment when you talk about customer service. But it's really there because even if you had no AI whatsoever, right, and you just said go use web chat instead of calling me. If someone calls you, it's a one-on-one conversation. If it's web chat, it's realistically typically a 1-to-4 conversation. So one agent serves 4 customers at once. Maybe it takes longer, but you save a lot of money. Now, text is a lot easier than voice. And, not just because you get a perfect signal when people type, or very predictable, shorthands that people use when they type, but because there's much less user experience work to be done. You can like paste them links and they can go away and look at troubleshooting for their printer or whatever they're, calling you about. But you can also like show them images. You can have them input information from a drop-down menu instead of actually having to understand what they said, right? And when you think about most chatbots, especially the very successful ones, and there have been very successful chatbot companies that are chatbot companies in the loosest sense of the word, right? Like say if you look at Lemonade. Lemonade is a platform for buying insurance for people our age, and it's hugely popular. I think that they've either IPO'd recently or they're about to, and but that's a good use case. But you know what? Like that's actually only a chatbot because it was an easier user acquisition strategy, right? You can go and download the Lemonade app, register in there, or you can just start a conversation on Facebook Messenger or WhatsApp. So like easier user acquisition, why not, right? Don't install an app if you're only going to talk to it once or twice, like per year. But that's cool, but it's really just shoving an app into a chat screen. So that shouldn't be conflated with the bigger undertaking of really automating customer service or customer support conversations. Because they're hard, they're very complicated. They're complicated because of some inherent operational inefficiency that has to be addressed through those processes, or it's like troubleshooting a very complex product that you bought, or complaining about something. And all of those things require either very deep knowledge of the processes or a high degree of emotional intelligence, right? If someone's complaining, then you really need to, if you don't want severe repercussions for your business, or you want to like mediate and find a good solution, you need to put a really good agent on it, right? And then like that's the reason why chatbots have not been able to do that, because they can do a certain number of things that they've done. Their ROI, even when they are there to deflect 5-10% of the calls, is not bad. But where the whole thing converged and why that hype cycle died off is text or chat went from 10 to 15% roughly across all industries, right? And then it kind of stopped, right? And voice is stable. It went from maybe 70 to 65, right? Like 65% of contact is still a lot of contact, especially when it's all one-to-one conversations. And really what you need there is you need to automate voice. But that's really, really hard. And it's hard for a few reasons, right? It's hard because the tech giants are not really interested, because they don't do enterprise, not in that way. Amazon is like, and Microsoft are the ones that are kind of looking at it, but it's complex, right? They're waiting for someone else to figure it out. And for them, between themselves, it's part of their cloud wars, where like, are you sitting on AWS or are you sitting on GCP, right? And if you're sitting on Google, please use my speech recognition when you build your voice. And like, I'll make sure that speech recognition is better than anything you'll ever build. And it is. Google is like amazing at speech recognition, right? And on top of it, because building a conversational application is much more than just like, I am best in natural language understanding. If that were the case, PolyAI would already be a unicorn. And we're not a unicorn yet. To really build value for that enterprise client, you need to understand their processes. You need to understand their user base. You need to convince them that this is worth deploying. Now, the ROI is clear. Like it is, it is a really good investment if it works. But people are not yet willing to believe that it works, right? So like you're asking, an enterprise buyer to maybe risk their career by saying like, hey, like I'm going to pay this little company a few million to do that, right? And like, that's no small feat. It takes a bit of courage. It takes quite a lot of courage, actually. But the thing that is good now compared to say 5 years ago, and just to give a bit of context, I went into dialogue by working for another conversational AI company called VocalIQ. And back at that time, we worked with automotive companies, and it was 2014, right? Like Alexa wasn't a thing yet, and Siri was like 3 commands you could do on an iPhone. And at the time, we were quite far ahead of our time in what we were trying to build. We were trying to build a self-learning API that anyone could use to build these things. And we ended up acquired by Apple in 2015, and that was the end of that one. But if at that time you told me that I'd be having 2-3 conversations a day with CIOs of, like large publicly traded companies, where I'd be convincing them that this could be really good for their business, I wouldn't believe you. Like no one at that company would have believed you. To be like, come on, like, give me a break. Today I'm having those conversations, and they don't always work. And a lot of people go like, you know what, that's really cool. And then they're like, but now it's not the time. right? And that's because, it's a pretty serious bet that they need to take. But it's happening, right? And, if you look at a few systems out there, there have been good deployments. They're not great, but they're good. And, we've got a few right now, and I think that people are slowly starting to believe. Now, the hype, I don't know if we've got a proper hype yet. There's a general AI hype that, fortunately for all of our companies, has not subsided. Like, there's funding around, although we'll see how COVID impacts that. But the general hype around voice AI, I hope, at least for my sake, is only coming. Right, but there will be a winter, and then there's the typical Gartner hype cycle that looks something like this, right? And I think we're still here with voice AI, but chatbots, yeah, I mean they definitely went up there, and they deflated quite a bit harder than your average set of technologies.
Oof, you put a lot of things there, and yeah, I think you get you make a good intro to my next question. PolyAI is a startup where apparently you're making some results on the market, and I know it's really difficult to find proper use cases to explain people what's possible, what's not possible, why they should invest or not. But you also mentioned that a couple of years ago you was part of Apple Siri team there in England. Can you just compare daily activities in that period today? As you mentioned, okay, now you are in the business position, which is pretty different. But what's different? What's different on the market?
I mean, I can tell you what's different between the work that we're doing, and I can also tell you Siri doesn't really have a market, right? Siri is part of your phone when you buy it, right? It's something that's there. It's a product that serves many customers in very different needs, right? Like, a lot of people will use it to set an alarm or to ask about, a football game. And for that, it works pretty well. You'll ask about the weather, it works pretty well. You may try to do something more complex, it may or it may not work. It's a huge, huge endeavor, right? And without going into too much detail, Siri was the first thing out there. And that's both a good, but also a very bad thing, because you get to make all the mistakes first, right? But it's also a living thing that's interacting with millions of users daily. And updating a thing, changing a thing that is used by so many people is a very serious endeavor. And from that perspective, it's a really, really big technical challenge, right? But it's a less well-defined one than what we are doing at PolyAI, where we have a few enterprise clients for whom we're doing a very specific thing and trying to do a really good job around making their customer service better. So just from an engineer's point of view, now is a much better time to actually just focus on a task and do a good job. Say for the restaurant group that is a client of ours, it's just a matter of are more people booking because they're using our system? The answer is yes. Close to double-digit percent. That's amazing. It's hugely rewarding to see that kind of business impact. And whether you're an engineer or on the business side, it's hugely rewarding because we're all part of it. We're part of winning the deal. We're part of customer success, to product, to kind of development, support. It's hugely rewarding, right? And the thing with virtual assistants is they're the aircraft carriers of the modern tech companies. Because if you think about it, they're there to display power, right? They show everyone how good Google's machine learning is or how good Amazon's text-to-speech is. They're basically giant advertising products, right? And there's a myriad of other reasonings behind why Alexa will make money for Amazon. They haven't really panned out. People aren't really shopping. The reports that were leaked around how many people, bought an item is something like 2%. And half of them never bought an item again. So, that number is, maybe it's a matter of a very long adoption curve. Maybe it changes over time. Who knows? Amazon's a very serious company. I'm sure that the planned ROI is there. But when you just think about these things, they're there to, display power. And they're putting a lot of money in it. If you do some mental math around, how much Amazon must be spending on Alexa with its 14,000 people, 14,000 people. That's more employees than most tech companies. Like there are probably like 20 tech companies in the world that have more employees than that, right? So it's a huge, huge effort. It's something like, the ancient pyramids. And whether it turns out to be as useful as ancient pyramids or more like that, we'll see in the end. But it's done a world of good in kind of like just helping everyone believe that these things are getting there, right? And, like 1 in 4 American homes, probably more by now, have an Alexa device, right? And like that's some pretty serious user adoption, right? In terms of like, even if they're using it just to play music and set alarms. So I don't know if this answers your question around how the world is different. The world has changed. Like the adoption is there, and for us working in this field, before and after kind of like the Alexa lightning bolt hit, like it's very easy to explain to people what you do now. Previously, it sounded very futuristic and very far-fetched. Now, we're able to go and convince CIOs of big enterprises that they should be buying this. My life is completely different. Back at that time, I was a machine learning researcher, happily training away, giant cross-lingual collections of word vectors and training, the first data-driven, word vector-based NLU models for dialogue. I had a bunch of fun doing that. And a lot of that work has found its way into our tech stack. But man, I've not written a line of code in 3 years. So it's very different.
My colleagues say he's an ex-engineer. It's a dark side.
Yeah.
When you start with like dealing with business elements. But in a period like, okay, you wanted to build your own company, PolyAI, successful company, where I strongly believe that in the next couple of years, you will have a really, really nice results. But in the moment when you start, okay, we have like, we have people who are from the technical point, really skillful. On the other hand, okay, we need to make a business from it. What was your thinking in that period? Okay, you're pretty like not able to go horizontally with different kind of cases, etc., where you can build some kind of models that will show the monetization and the return of investment for the clients, etc. Do you think that in that period it was challenging for you to narrow it, or you was like just push to see, okay, this is only the group of cases where I can build something?
No. When we started, I've got 2 co-founders. Both of them are Taiwanese guys who came to Cambridge to do dialogue, very technical, best paper awards from ACL and EMLP. So all 3 of us were technical, right? So the lack of business acumen at the start was very, very tangible. And, we worked with big tech companies to help them advance their virtual assistant features. We worked with an augmented reality company. We worked with an automotive. We were all over the place. And, we said no to a few acquisition offers, and then we were like, all right, what are we doing? Like, are we like, who are we selling to? How are we going to build an empire, right? And really the thing that is the biggest market that, we just gravitated towards because it is an insanely big market. It cannot be quantified. It is in the trillions. By some estimates, it's bigger than the global defense industry. Customer service is huge, right? And like this technology will disrupt it eventually, right? Maybe we're successful and we, get to automate 10% of all customer service calls that happen on the whole planet. That is what we would like to do. But it will happen eventually, whether we do it or someone else. So from that point, when we kind of like homed in on customer service, the world got a lot simpler. Then it's just a matter of like, are you going for a specific vertical? Are you going for a horizontal approach where you have use cases like, say, appointment making or troubleshooting that can be used in areas as diverse as like hospitality, healthcare, telcos. For a while, we were following a horizontal approach. And right now we're kind of building, it's enterprise software. Like we're talking, like smallest deal size, $500,000, right? When you want to do that, you're going to have to customize, right? And that's the mess and the pain of enterprise software. So when you do that, like you take the set of horizontal use cases you've built, and then you have to basically turn them into a very custom product for the end buyer. we have a lot of thoughts about how we counter this later on, but you need a good channel partner strategy so that you don't end up picking up infinite amounts of professional services and becoming a consulting company, because that would be a very different thing to what we set out to achieve. But if you look at companies like, say, UiPath, they've done a spectacular job at just like creating an ecosystem around them where like they're the core, and everything else is just like an ecosystem that they support. But it's a bit too early to say. I think that for conversational AI, it's really all about making people believe. We have a window now. If we use it smartly, in the next 2 to 3 years, we'll show that we can do 6 different things, different domains really, really well. If we do that, there will be enough funding and enough interest from other clients to build an empire on it. If not, we'll go through another winter, and there will be interest again in 5 to 10 years. But I think we'll crack it this time around.
I believe so. Yeah, I think currently like we have enough data, enough people who are eager to build something. On the other hand, like companies are now struggling to find a new company, new deal that could solve their problems, etc. But like for like regular people, they're probably asking like currently, okay, what will happen with us? If we are talking about like a conversation and understanding, those are like, I would say, main features of us in some sense. And people are pretty, I would say, maybe afraid of these kind of conversational systems that are already like affecting their own jobs in some sense. We have situations that like call centers now in some domains are just switched with some systems like PolyAI has, etc. How do you see that people from those kind of roles will actually will evaluate in some sense? They will go some other direction.
Yeah. I mean, look, this is something we grapple with a lot, and like our goal is not to put people out of work, right? But technology tends to do that. Like
that will happen.
It, like we used to, plow the fields manually, and now we don't. Like, and we have technology that makes that job for those people that do it a lot more pleasant than it used to be. And people who really want to, say work in agriculture can still work in agriculture, right? And it's a more enjoyable job. And I think that what's going to happen in customer service is the same thing. I've been to a lot of call centers, from Glasgow to Newcastle to, places around Wales that you've never heard of, and, all parts of England, mostly in the UK. But those people do a heroic job. Like, they're the unsung heroes of our society, like pleasant and polite and conversation after conversation where people were, frankly, going way below the border of decency, and not considering the fact that it's not this person they're speaking with who misplaced their shipment, and being a terrible human being to them will not actually even help them with their end goal, but they're just venting at that person for probably other problems in their life as well. There's a huge need. Like, technology will never replace those people, because there's a huge need for, you can split it into 4 quadrants. Like, kind of like, is it high value for the enterprise, and is it high value for the user, right? If it's high value for the user and low value for the enterprise, that's where good automation has the most to offer, because those are places where you spend 30 minutes waiting for a call center agent to pick up because there aren't enough of them. And in those cases, there will still be a call center agent there to pick up the call when the technology fails to work, which will always happen, some percent of the time. Maybe you have a particularly strong accent, or God knows what is going on, right? And then you'll get that person to pick up more quickly, and technology will just improve your customer experience. For the high value tasks, if you're like, say, selling, and you're selling well, you won't be automated, because technology will not be better at, I don't know, if you're calling, someone from your particular region and you hear the accent and you make a joke about it. That's how you sell. People buy from people. They don't buy from technology. So a lot of the high value jobs in that sector are there to stay. They will stay, right? As long as there's like a good economics for them. For jobs where there aren't enough people manning the booth right now, you'll see automation, and like customer service as a whole will improve. will some, it will affect employment, no doubt. And the unit economics affects employment, in different places of the world. And, we've seen customer service move from, say, the UK to India and then back because, people like speaking to people who have similar accents to them, right? So, yeah, no doubt there will be an impact, but it's not as strong as people think. I actually think that AI will have a stronger impact in, other places where there's like a more serious element of decision making involved, right? And there you get those really ethical concerns around whether you should or should not use AI. But even there, often it's really there to help the human do a better job. Like, there's a company in London called Chiron that does radiology. And if you use their software, like radiologists are far, far better at detecting cancer than they are on their own because the predictions are not correlated the way they are between humans. So like we'll get a lot of good things out of AI. And I think that, anyone who's ever tried to train a machine learning model to like predict anything. I see questions about Serbian, for example, and training like, NLP models in Serbian. Like if it was that easy, if AI was that powerful, like we wouldn't be asking those questions, right? It's just, it's not there yet. There's no need for fear mongering.
Yeah, I agree totally. Man, in that domain, like currently we have like systems that are like augmented part where they are actually assistants to us. In sales, you mentioned like sales is a really tough like problem in some domain, but there are companies, I think there is one Gong.io.
Gong.io is a great company, yeah.
Israel, they are doing really awesome things like helping like salesmen to be more productive with their analytics that is a real-time analytics in some sense, etc. And that's really powerful. I think that will empower even more like new jobs in some sense. Definitely some will need, some of them will be like turn off, but we need to be more agile in some sense. Because we are powered, yeah, as a Serbian AI Society, we are part of it. There are questions from our attendees. Did PolyAI develop any system products for Serbian or communication in Serbian?
Mm-hmm. I've got a demo. If you want to see it, drop me an email, Nikola@polyai.com. It's not particularly polished because we don't have any Serbian clients. It was really built by a French engineer who did it just to entertain me, and I was entertained. We had to use, I think, Slovak text-to-speech because Google doesn't yet support Serbian text-to-speech. But speech recognition works really well. It's insane. Like it tells you about the power of data.
And we have a question from George Božić. How do you handle internal reasoning of the conversational model, provided we can perfectly decode the question and have a perfect model that could generate a natural language answer? How do you find out which answer the model needs to give, and how does the model store the information it needs to use in order to generate the answer? Is reinforcement learning used in any part of the pipeline? And if it is, how it's learning task defined?
This is not a question. This is a conversation. Look. I think that to touch on reinforcement learning is something that one of my co-founders and a large part of our research team has spent a lifetime doing. It's really interesting. The difficult thing with reinforcement learning in dialogue and how it's different from, say, playing Go or chess is that it's a harder class of problems. It's not a Markov decision process. It's a partially observable Markov decision process because you don't actually, it's an asymmetric problem. It's not a game that you play with the same rules. So it's the other layer is that you don't have like perfect decoding, right? You could perfectly decode if it's text. And even then, like there are ambiguities in language. If I say like, I want to book a table for 2 at 4, like, or well, you can ask that question in a way that makes it confusing, right? And like it can be ambiguous. But if you could decode it perfectly, how do you then decide which answers to provide? Read our paper about our convert encoder, and you'll see where we share that quite freely. But in terms of reinforcement learning, it's not a silver bullet. It's an incredibly enticing and interesting research problem, but it's really, really hard. And if you look at any production-ready dialogue system deployed out there, it doesn't use reinforcement learning.
One interesting exotic question. Do you have some experience with the AGI?
I mean, look, I mean...
Do you believe in AGI? That's maybe the better question.
No, I do not. I mean, as you can probably see from the conversation, I believe in things that you can like evaluate clearly. I think that we'll get closer to having much better tools by having a very clear approach. I think that like data-driven models are a great way to build functional systems. I see very little evidence that we've imbued any of these models with any kind of self-awareness capability or even the ability to figure out the right architecture. They're very good tools. They're really great tools, but guess what? So is Microsoft Excel if you do, investment banking. Like, it's a really, really good tool. And like, yeah, these models might help you trade on the stock exchange, or they might, help you understand what, the person meant when they sent the customer service query. But like, we're so far from AGI. But yeah, it's good to stay excited.
Share the same views. But you're also part of the Serbian AI Society. In the introduction, I mentioned that Serbian AI Society is an organization where actually we saw that there are a lot of really smart people that are originally from Serbia, all over the world, like doing really awesome things. And we also had that idea to try to connect them, to try to find the ways how actually we will make some communication between them to also boost innovation, to boost communication between them in some sense. And you're also one of the AI minds in our organization. What do you think about like communities? Do you believe in communities? And actually, can you share like why you are part of Serbian AI Society?
Look, I mean, I'm like hugely keen on Serbia. I've not lived in Serbia for 10 years, but like, it's my country, my people. And I think that we've got a lot of good people. I think that, our IT segment of our economy is what can really, drive the country out of, its current economic predicament. And, I'm hugely bullish on Serbs around the world, and like, frankly, there are far too many of us outside of Serbia and, other parts of the Balkans where we're indigenous. But hey, like, I think we can do a lot. And I think that, a lot of our people maybe don't spend enough time kind of like working with the Serbian IT sector. And it's not easy, right? You're kind of like, you're abroad, you're trying to just, do what's best for your company or your job, etc. But I think that, you mentioned Gong.io in Israel, right? And I spent a month in Israel 2 years ago. And when you look at that country, I mean, they're known as the startup nation, and they're spectacular at doing it, right? Like, they share some resemblances with us. They're far ahead. But in terms of like, they started off with a population that's incredibly technically savvy, as are Serbs, right? Like, we fetishize mathematics. We're very good at it. Our education system is pretty robust in the sense that we still have a lot of really good, mathematical people, engineers, etc., coming out of our education system. And, in IT, like, the fact that, I don't know, we couldn't jump on the hardware bandwagon where, say, Taiwan made a fortune, like, it doesn't really matter anymore. Software has democratized it quite a bit. And, I think that more and more, even in London, I hear of people who are using teams in Serbia to build their companies out. Not like outsource people for a month, but like, real companies doing some really cool stuff. And I hope to be part of that one day. And, I don't know if PolyAI will ever have a Belgrade office, but I would really like PolyAI to have a Belgrade office. And I think we've got a lot of talented people. I think that, all of Europe is far behind America, even behind Israel, in terms of technology, right? We are, broadly as a whole continent, we are a pool of technical labor, right? We build companies that we sell to American companies for the technology and for the insanely talented engineers. We're not good enough at product. We're not good enough at selling. And inherently, we are at a disadvantage because the market is, I mean, Europe is a big market, but it's hugely segmented. It's segmented by language, different legislations, various barriers to entry. And, if you build a thing that works really well for, hotels in Belgrade, like, well done. You can sell it in Novi Sad, and you might sell it in Montenegro and in Croatia. Like, well done. You were just sold to 20 million people, each of whom earn 10% of what an American does. So like if you did the same thing in America, like you will win. Yeah, and then you'll go and you'll win other markets as well, simply because you've got all the funding and a better product. So I think that, we need to learn a lot, and I think the Serbs abroad need to learn a lot and then bring that knowledge back, if it's possible. It's a hard challenge. Like much bigger and more prosperous nations than Serbia have not cracked the challenge. So like, will we do it? I don't know, but it's on us to try.
Exactly, that was lovely put. That's idea with the Serbian AI Society to try somehow to organize people and to push. We are pretty good. There is a good term, inat, in Serbish,
Absolutely.
and we need to use it properly. And yeah, Nikola, this was really awesome today, and thank you so much for being with us tonight. And I hope to see you soon in Belgrade with PolyAI.
Absolutely. Absolutely. Thank you for having me. This was a pleasure.
Thank you so much.
And everyone, thank you for listening to us.
Thank you, guys. Bye.
Cheers. Bye.